Okay, this video is to help you with the homework, some of the tricky problems in the limits homework number 2. So this is the homework assignment that I'm doing. Let me go to this first page here first. And this is the page that I'm actually doing, is I'm doing this one right here is limits to pages 111 through 1 through 27 odd. So this was the assignment I gave you. This is all the work. As you can see, I've worked it all out. I'm not going to put this up quite yet, so I wanted to do some of the tricky ones each with you as you go through. You have all the answers to this, so I'm going to do some of the tricky ones that I did in class, all right? So the first one I did in class was let me see now, what was my very first one I did in class? Was 15. So if you want to watch this later as you get to number 15, that's totally up to you. But I wanted to help you on one of the ones I thought would give you some trouble. So 15 asks you for the limit as h approaches 0 of 4 plus h squared minus 16 all over h. All right. So when I look at this one right here, the first thing I always do is I substitute in and make sure that the limit isn't right away there. So I'm getting my pen all set. So I stick a 0 in there. I get 4 squared is 16 minus 16, so it's 0 if I stick it there. So I 0 over 0. So I have my indeterminate form. I always do that first. And then the next thing I try to do is see if I can do some algebra. And I look at it and say, well, I mean, it's not like there's a radical to rationalize. There's nothing really there to factor. So I'm going to try to maybe multiply this all out and see if something simplifies. So every time you do something until you plug in that 0, you write the limit as h approaches 0. And then I actually multiplied 4 plus h squared out, which is 16 plus 8h plus h squared minus 16 all over h. And then I look at this and say, oh, cool. Thanks for playing. These cancel out. My 16s cancel out. So again, I keep writing the word limit. I have the limit as h approaches 0 of 8h plus h squared all over h. Now I again try to put my 0 in there and I still get 0 over 0. So I'm thinking, is there any more algebra to do? And I say, wait a minute, I can factor the h out of the numerator. So I say equals the limit as h approaches 0 of h times 8 plus h all over h. Then I see I have these two factors here. I can, thanks for playing, that divides out to make a 1. So it's really the limit as h approaches 0 of 8 plus h. Now, as soon as that happens, I now know I can plug my 0 in. Please show me, and it equals 8. So I'm modeling to you exactly how you should do the work. Please don't do numerous steps in one step for me to figure out what you're doing. I want to see how your algebra is. And I want you to notice every single time I write this, the limit, oops, I didn't mean to do that. Let me undo that, is I write the limit here. I write the limit here, here, and here every single time until I actually put in the 0. After that, you don't need to write the limit anymore. So I think sometimes I scare kids because I say you better write it every time. But as soon as I put that 0 in, notice there's no limit here. You just say equals 8. Okay, so I thought that was a tricky one. The next thing I did in class was 17, and the kids were really glad I did it because of all of them, it looks the shortest, but it has a little trick to it. And so this might make your brain hurt because you did do this in Algebra 2, is the limit of x plus 2 over x cubed plus 8. That's a 3, guys. That's a 3. It looks kind of squishy. Let me try that again. Let's try that again. So it's x plus 2 over x cubed plus 8. So I do what Mrs. Pond says. I plug the negative 2 in. I get 0 over 0. So that's my indeterminate form. I can't do it. And I'm like, what kind of algebra can I do? I don't know what to do. And then I thought, well, what if I found out if x plus 2 is a factor of x cubed plus 8? All right. So if I take x cubed plus 8 and divide it by x plus 2, if it goes in evenly, then it's a factor, right? So now we're going to do long division. So this is going to kind of take you back, but we're going to do some long division just to see if x plus 2 is in fact a factor of x cubed plus 8. So I'm going to do x plus 2. I want to see if it goes evenly into x cubed plus 8. So remember when we do this, we got x cubed, but we got to have a 0x squared plus a 0x plus 8. Now I promise you this won't be on a quiz, but I want to remind you how you did this. So remember, we look at this first term here, this x in here, and I say, well, how many x's go in x cubed? Goes x squared, and then I'm going to multiply both of those by x squared. So that's going to be x cubed plus 2x squared. Draw the line, change the signs. So this is a minus, That cancels out, so I have a negative 2x squared. Bring down the 0x. Again, you're looking at this x squared and this x. You're always looking at it then. I said, how many x's go into negative 2x squared? Well, minus 2x goes in there. Then when I multiply it, I get negative 2x squared minus 4x. Draw the line, change the signs because you're subtracting. That cancels. Now I have a positive 4x. Bring down the plus 8. Now x goes into 4x how many times? Plus 4. I hope this kind of brings back to memory what you did this, and then you've got 4x because you have done this, plus 8. Draw the line, change the signs, and I have a 0. So in class, they asked me, well, what's that got to do anything? Well, that means this goes in there evenly. So I actually can write this as the limit. So this is the long division, the limit as x approaches negative 2 of, ready, x plus 2, wait for it. And now I can write this as x plus 2 times x squared minus 2x plus 4. And I know you can factor that some more, but the whole point is now, look what I can do. I can cancel that. So by me finding that it went in evenly, it's a factor. So that helps me out a lot. So I can say, thanks for playing. That's 1. All right. So I'm kind of running out of room over here. So I'm going to say equals, this is the work that went the limit as x approaches negative 2 of 1 over x squared minus 2x plus 4. And then I want to see, usually if there's a number in the numerator like that, it really does, you can plug it in. So I'm going to say equals 1 over, and I'm actually going to substitute the negative 2 in now and see if I get a nice number. So 2 times negative 2 plus 4. And when I do that, I got 4 plus 4 plus 4 is 1 over 12. So that's the limit of that one. And I wanted to do that with you because I know some of you aren't going to know or recall that. And I promise you again, that won't be in a quiz, but I wanted to remind you how to do that. Okay, so far I've done 15 and 17. I'm going to add a page. And I'm going to do the last one of this assignment that was a little bit tricky, was number 23. I have the limit as t approaches 0 of 1 over, whoops, that's messy. Let's try that again. 1 over t radical 1 plus t minus 1 over t. Okay, so a lot of times when students are doing this, they're like, basically they're starting this, and I'm like, what do I do? Well, the first thing is you always substitute. So if I plug a 0 here and a 0 here, I'm going to get 1 over 0 minus 1 over 0, and this doesn't tell you anything about the limit. So I try to see if there's some algebra I can do. And the only thing that comes to mind is, well, what if I got that to be just one fraction? So I'm going to find a common denominator. So this equals a limit as t approaches 0 of, and I'm going to write this as one whole thing, okay? And I know my common denominator is going to be t radical 1 plus t. So the 1 is going to stay there minus, now what am I missing here? So my smart 1 is going to be, I'm missing a radical 1 plus t because t's already there. So I'm going to do a radical, this is a radical 1 plus t, radical 1 plus t. Now I have minus, ready, 1 times minus radical 1 plus t. Okay, so now I have it as one fraction. That's good. But now this brings to mind, well, if I have a radical like that, can I rationalize a numerator? And yes, you can. So I'm going to multiply this by the conjugate, which is 1 plus radical 1 plus t over 1 plus radical 1 plus t. Now I get the denominator is going to be ugly, but the numerator will be really nice. So this is the limit as t approaches 0. Now when I multiply the numerators like this, remember, we picked the conjugate for a reason. I got 1 times 1 is 1 minus, and the key to this, if I have radical 1 plus t times radical 1 plus t, it's 1 plus t, and don't you dare forget those parentheses. And the denominator, I know it's ugly, but we all can't be beautiful. And I'm going to put a nice bracket there, and there we go. So now the numerator is kind of nice. So then I go, all right, this is a 1, and I'm going to distribute that negative, minus 1 minus t. Thanks for playing. So this comes out to be the limit as t approaches 0 of negative t, okay, all over t radical 1 plus t times 1 plus radical 1 plus t. Isn't this so pretty? Then I say factor, factor, factor. I can cancel these and make a negative 1 at the top. So now I have the limit. Notice I keep writing limit because I haven't plugged anything in yet. I'm just trying to use algebra to get so I can plug a 0 in. So I have radical 1 plus t times 1 plus radical 1 plus t. I have a number in the numerator, so I bet you I can plug my 0 in. So I'm actually going to do that. Again, if I actually substitute in, the limit goes away, and I actually substitute the 0 in wherever there's a t. Okay? And that's the square root here. Let me erase this. Sorry, I didn't mean to confuse you. It's 1 plus the square root of 1 plus 0. Sorry about that. Okay? So when I do that, it's negative 1 over 1 times 1 plus 1. So 1 times 2 is negative 1/2. So you got 1 times 2. So this is the limit, is negative 1/2. So I hope by doing some of those strange ones for you that this will help you. And if you have any other questions in the assignment, please let me know. That's the end of this video.